Hello friends and my dear students, welcome back to my channel Phoenix Physics. Today we are going to learn effect of dielectrics in capacitors. Before going into this topic, you have to recall three formulas. We have already studied these formulas. One is C. What is C? C is nothing but capacitance. Capacitance C is equal to Q by V, and the potential difference V is equal to E into D. E is nothing but electric field. Then energy U is equal to half Q square by C or half CV square. You know that capacitor consists of two parallel metal plates separated by a small distance. We assume that the space between the two parallel plates is either empty or filled with air. Suppose mica, glass or paper introduced between the plates of the capacitor, the capacitance is altered. Let us see how the capacitance of the capacitor is modified when the dielectric is present. There are two cases. One is when the capacitor is disconnected from battery. Look at the diagram. Consider a capacitor with parallel plates, each of cross-sectional area A and separated by a distance D. This capacitor is connected by the battery and the potential is V0 and the charge stored is Q0. You know the formula, that is the capacitance. The capacitance of the capacitor C is equal to Q by V. This is general formula. Now, before introducing the dielectric material, the capacitance of the capacitor is C0 is equal to Q0 divided by V0, because initially we have V0 potential and Q0 charges stored in the capacitor, so the corresponding capacitance is C0. I have written this formula from this equation. So the capacitance of the capacitor without dielectric is C0, that is Q0 by V0, or we can write epsilon naught A by D. What is epsilon naught? Epsilon naught is permittivity of the free space. Then A is cross-sectional area of the plate. What is D? The separation between the plate. We have already derived this formula also. So either you can write C0 is equal to Q0 by V0 or epsilon naught A by D. This C0 is our equation 1. Next, I am going to find out the potential difference denoted by the letter V0, because the initial potential difference is V0 here. So what is V? V means ED. Here V0 means you can write E0 into D. Say this is equation 2. So E0 is nothing but electric field inside the capacitor without dielectrics. Here the electric field lines start from positive charge to negative charge. So there will be more lines if there is more charge. Now the battery is removed, dielectric material is inserted between the plates of the capacitor. After introducing the dielectric material, the V0, what is V0? V0 is nothing but potential difference. V0 decreases. Why? Because we removed the battery, so V0 decreases. Obviously E0 also decreases. Why did I say E0 decreases? Because you know the formula, V0 is equal to E0 into D. Here the separation between the plate is same, so this one is same. V0 decreases means E0 also decreases. Or we can say, when you introduce the dielectric material, the molecules in the dielectric materials are polarized by the charged plate. This produces the layer of opposite charges on the surface. So this will reduce the electric field. See, this is our E0 electric field. Molecules produce internal electric field E. Compared to this E naught, E is small. That is why I said electric field E naught is reduced by the dielectric material. Now the new electric field is E. What is this epsilon R? Epsilon R is nothing but relative permittivity of the dielectric material, or simply we can say dielectric constant. So this new electric field
E is equal to E naught by epsilon R.
Say this is our equation 3. Another important point is this epsilon R is always greater than 1. Don't forget this. Epsilon R is always greater than 1. Here E naught is reduced by the dielectric material. So this new potential, after introducing the dielectric material, the electric field becomes E. So this E is less than E naught. What about the potential difference? Initially, the potential is V naught because of this battery. After removing the battery, the potential decreases. So the new potential difference V is equal to E into D. Here substitute equation 3. V is equal to E naught divided by epsilon R into D. What is this E naught D? E naught D is nothing but V naught. V naught divided by epsilon R. The new capacitance of the capacitor. When you remove the battery, V naught decreases. Same way, E naught decrease to E. Then what about the charge Q naught? Initially we have charge Q naught, right? After introducing the dielectrics, the charge remains constant. You know the relation capacitance C is equal to Q by V. When you introduce the dielectric material, the potential decreases. So V decreases means C increases. What is C? C is nothing but capacitance. Then what about Q? Q remains constant. Why did I say Q remains constant? Because I removed the battery. Capacitor has more place to store the charge, but we don't have battery. That is why I said
the charge Q naught is constant.
Then how do you calculate the new capacitance? New capacitance is C, which is nothing but Q naught divided by V. Substitute equation 4 is equal to Q naught divided by V naught into epsilon R. What is Q naught by V naught? Q naught by V naught is C naught. So Q naught by V naught is C naught. So simply you can write C naught epsilon R. Here also epsilon R is greater than 1. When you introduce the dielectric material, the capacitance increases. So the new capacitance is greater than old capacitance C naught. So when epsilon R is greater than 1 means C is greater than C naught. This is my equation 5. From equation 5, C can be written as C naught epsilon R. Instead of C naught, you substitute epsilon naught A by D. Epsilon naught A by D. Here I have epsilon R. So one formula is there. Epsilon R is equal to epsilon by epsilon naught. Suppose I need epsilon means epsilon equal to epsilon naught epsilon R. This is one formula. Substitute the formula here. So instead of epsilon naught epsilon R, you can substitute epsilon. So C is equal to epsilon A by D. This is equation number 6. The energy stored in the capacitor without dielectric. Energy means you can mark it as U. Without dielectric means U naught. You know the formula. U is equal to half Q square by C. Here this is U naught means this is Q naught square by C naught. Energy stored in the capacitor with the dielectrics. With the dielectrics means you can write it as U, that is half Q naught square divided by C. Why did I write Q naught square? We know that Q naught, the charge Q naught is constant, have written Q naught square. But when you introduce the dielectric, the capacitance of the capacitor is increased. So instead of C naught, I have written C. So half Q naught square by C. Substitute equation 5. What is our equation 5? U is equal to half Q naught square divided by C naught epsilon R. You know that half Q naught squared C naught is nothing but U naught. So you can write U is equal to U naught divided by epsilon R. This is our final relation. Here also epsilon R is greater than 1. Here epsilon R is greater than 1 means both are inversely proportional. So U is less than U naught. The energy stored in the capacitor is decreased when the dielectric is introduced between the plates of the capacitor. Why? Because the capacitor spends some energy
to pull the dielectric inside.
This is your conclusion. Case 2, when the battery remains connected to the capacitor. Here the battery is connected to the capacitor. So the V naught is constant here. Why did I say V naught is constant? With or without dielectric material, the battery is connected to the capacitor. So V naught is constant. Then what about electric field? E naught? E naught is also constant. Why did I say E naught is constant? See, V naught is equal to E naught into D. Here V naught is constant, D is same, obviously E naught is also constant. So E naught is constant here. What about Q naught? Q naught is charge stored in the capacitor without dielectrics. Then Q is charge stored in the capacitor with the dielectric. Faraday experimentally found that when you introduce the dielectric material, the charge stored in the capacitor is increased by the factor epsilon R, that is epsilon R into Q naught. What is this epsilon R? Nothing but dielectric constant. The capacitance of the capacitor is increased. C is equal to Q by V. Initial capacitance is, the capacitance without dielectric is Q naught by V naught. New capacitance is C is equal to Q by V naught. Because V naught is constant, Q increased by epsilon R times Q naught. So instead of Q, you can substitute Q naught epsilon R divided by V naught. What is Q naught by V naught? That is C naught. So C is equal to C naught epsilon R. This is our equation 1 and this is our equation 2. So in both the cases, whether the battery is connected to the capacitor or removed from the capacitor, the capacitance of the capacitor is increased. This is one of the conclusion. The capacitance of the capacitor with the air medium is C naught is equal to epsilon naught A by D. The capacitance of the capacitor with the dielectric medium is
epsilon A by D.
The energy stored in the capacitor without dielectric. U naught is equal to half Q naught square divided by C naught. What is C naught? C naught is nothing but Q naught divided by V naught. This is general formula. From this I want Q naught means you can simply write it as C naught into V naught. Substitute the formula here. So U naught is equal to half Q naught square means C naught V naught the whole square divided by C naught. So U naught is equal to half C naught square V naught square divided by C naught. Cancel this. Finally you can get U naught is equal to half C naught V naught square. Say this is my equation 3. Energy stored in the capacitor with the dielectrics. U, here same formula only, half C into V naught square, because C increased because of this dielectrics but V naught is constant. Substitute equation 2. What is equation 2? C is equal to C naught epsilon R. So substitute here. U is equal to half into C naught epsilon R V naught square. From equation 3, half C naught V naught square is nothing but U naught. So U is equal to U naught into epsilon R. Epsilon R is greater than 1. So U is greater than U naught. Because here both are in the multiplication format. So epsilon R is greater than 1 means U is greater than U naught. So what is your conclusion? Energy stored in the capacitor is increased with the dielectrics when the battery is connected to the capacitor. This is your conclusion. Next I am going to calculate. Energy density is denoted by the letter small u, which is nothing but energy per volume. Volume can be written as area into D. Then what about energy? Energy is U is equal to half C, this formula, half C V naught square divided by this volume. Instead of volume you can write area into D. Capacitance C is nothing but capacitance. The capacitance C is equal to here V naught square, here also A into D. Again V naught is nothing but E naught into D. E naught D the whole square divided by D into D square into A. Further you can write half epsilon A E naught square D square divided by D square into A. Cancel this A, cancel this D naught D square. Finally you can get energy density U is equal to half epsilon E naught square. In this class we studied so many formulas. Let us put one tabular column. You can understand better. Here dielectric is inserted without battery means Q is constant, but with the battery Q increases. Then what about the potential difference? Decreases without battery. Here the potential difference is constant. Next one, E, V decreases means E also decreases. Here V constant means E is constant. Then capacitance, in both the cases whether with battery or without battery, capacitance increases. Without battery energy decreases. Here energy increases. I hope this video is useful.